How do you solve a crime when all you have are scattered digital breadcrumbs and a trail that's gone ice cold? Well, today we're going to talk about exactly that. We're diving into a fascinating technique called investigative reconstruction, which is all about piecing together the most complex digital jigsaw puzzles you can imagine.
Think about a crime scene for a second. It's never a perfect picture, right? It's more like a shattered puzzle. And as this quote says, you've got missing pieces, damaged pieces, even pieces that are deliberately hidden. Now imagine that in the digital world, where evidence can be wiped clean, altered, or disguised with just a few keystrokes. It's a whole other level of complicated.
And that right there is the big question, isn't it? For really sophisticated cyber attacks or, complex serial crimes, the standard playbook just doesn't cut it. The clues are all over the place, and the real story of what happened feels just out of reach. That's when you have to bring in a much more advanced method.
Okay, so here's our game plan. We'll start by really understanding this unsolved puzzle problem. Then we're going to take a much deeper look at what reconstruction actually is. After that, we'll get into the really cool stuff, reading behavioral imprints, before we cover the absolute golden rule of objectivity. And finally, we'll see how it all comes together in the final report.
So let's get into it. When the normal process hits a wall, investigators have to pull out an advanced tool from their toolkit, and that tool is reconstruction.
At its heart, this whole idea rests on a classic forensic principle you've probably heard of, Locard's exchange principle. The basic idea is that every contact leaves a trace. It doesn't matter if it's a footprint in the dirt or a failed login attempt on a server, something is always left behind. The job of reconstruction is to find those digital traces and figure out what they mean.
Now, this is where it gets really, really interesting. Look, physical imprints like DNA or fingerprints can tell you who was at a scene. That's huge, obviously. But behavioral imprints, they tell you the how and the why. Things like the specific software an attacker used or the sneaky ways they try to cover their tracks. That stuff tells you about their skills, their motivation, and their signature way of doing things. It's the story behind the crime. So how do they actually do this? Well, it's not just random guesswork. Investigators analyze these digital imprints in 3 very specific ways. Each one gives them a different piece of the puzzle, and together they build a complete picture of what went down. First up, you've got temporal analysis. This is all about the when. They build a super detailed timeline of every single event. This lets them see the whole crime unfold step by step. They can spot weird patterns, identify suspicious gaps in the data, and zero in on the most critical moments of the entire attack. Next is relational analysis, the who, what, and where. Think of this as drawing a map of the crime. Investigators connect the dots between all the people, the devices, and the data involved. This helps them visualize the exact path an attacker took through a network, showing how they got from the outside through the firewall and to their final target.
And the third piece of the puzzle is functional analysis, the how. This is all about what was technically possible and what wasn't. For instance, could the suspect's computer even open the files in question? Was it possible the files came from a disk instead of the internet? Answering these questions is critical for separating what could have happened from what actually did happen.
Okay, so you have all these powerful ways to analyze evidence, but using them correctly all comes down to one single, incredibly important rule. Because when the data starts to point strongly in one direction, the temptation to jump to a conclusion is huge.
And here it is, the golden rule, objectivity. An investigator's job is not to say who's guilty. Their job is to present the facts of the case, based only on the evidence, period. The minute they start implying guilt, they've crossed a line and put the entire investigation at risk.
And you can see just how important this is in the language they use. Look at the difference here. Saying a suspect distributed images implies you know their intent, but saying the images were found on their computer is just stating a verifiable fact. One is an accusation, the other is evidence. It's a massive difference.
And this isn't just a theoretical problem. When objectivity fails, the real-world consequences can be disastrous. In the Westerfield's murder trial, something as simple as misinterpreting a timestamp, whether it was local time or GMT, led both sides to misrepresent the digital evidence, which seriously damaged the integrity of the case. So, after all this careful, objective work, what's the end product? It's not just a hunch or a guess, it's a highly structured report that gives the investigation immediate, clear direction.
It's called a threshold assessment. The best way to think about it is as a strategic blueprint for the rest of the investigation.
It takes all the initial findings and uses them to figure out the most important features of the case and what the most effective next steps should be.
And as you can see, this thing is incredibly structured. It's not just a loose collection of notes. By systematically analyzing everything from the victim to the crime scene, the report is able to generate concrete, evidence-based suggestions. This helps focus the investigation, which saves a ton of time and resources.
So at the end of the day, in a world full of digital ghosts and fragmented clues, investigative reconstruction is about finding the story that's hidden in all that chaos. It's about being methodical, being objective, and carefully putting that digital jigsaw puzzle together, not to point a finger, but to simply reveal the truth of what happened.